Here's some inside info. You're going to make a lot of mistakes while programming. And not just as a new programmer. Experienced programmers almost never write perfect, error-free code. In fact, making mistakes and introducing errors into your games, known as bugs, is so routine that one of the things all programmers need to do is check for bugs and correct them, a process known as debugging. Even outside of debugging, which we'll talk about in a minute, there are a few things you can do to improve the quality of your code while you're writing it. First, before you even write a line of code, make sure you're clear on what that code is actually supposed to do. If you aren't sure how something in the game's design should work, get clarification before you start trying to implement it in code. If you're working with another designer, now is the time to sync up. And if you're working on your project solo, take off your coder hat and put on your designer hat for a little bit. As you start to work on your code, the single biggest trick you'll want to master is breaking your tasks into smaller chunks. Developers call this decomposition. For instance, let's say you need to implement a blaster in a shooter game. You might decompose this into several smaller tasks. First, capturing input, then getting that input to spawn the laser projectile, then determining the direction it should move based on which way the blaster is pointing, and so on. Rather than write all the code for all of those things at once, it's better to handle the tasks one at a time and then test to see that things are working properly before moving on to the next step. Working this way has lots of benefits. One is that it tends to keep your code more organized because all the code to accomplish something specific lives in one place. We call code like this modular. The other big benefit is that it makes debugging much easier. If you wait until you've coded up every step before you test and the laser blast doesn't work, you've got to look everywhere to find the bug. But if you know the first two steps worked and then something unexpected happens when you test the third, most likely the bug is in your code for that third step. When it comes to errors in code, developers talk about three major types. Syntax errors are like grammar or spelling mistakes in written or spoken language. For example, saying, "My brother and me went to the store." In that example, you probably understood the meaning even though the sentence is grammatically incorrect. But this is the part about computers being finicky. Computers can't work with code containing syntax errors at all. Code with syntax errors won't even compile or run. This makes syntax errors relatively easy to catch because most development tools can find and highlight them automatically, just like when your computer underlines words you misspell while typing. The second type of errors are logic errors. Logic errors happen when your code is syntactically correct, but an instruction it contains is different from what you intended. For instance, suppose you want a vehicle in your game to stop moving when it runs out of fuel. But when you test, you find that it doesn't move even with a full tank. You check your code and find that it contains a greater than sign rather than a less than sign, meaning that the vehicle will stop moving when its fuel is greater than 0. The exact opposite of what you intended. Unlike syntax errors, logic errors can't be detected automatically because the computer doesn't know what you intended your code to do. It only knows what you actually told it to do. Sometimes you can catch logic errors just by double-checking your code after you write it, but most often you'll find them by testing, seeing something unexpected, and going back into your code to track down the source. The final and trickiest type of errors are runtime errors. It's possible to write code that is syntactically correct and does what you intend, but still introduces unexpected or undesirable behavior when it runs. In games, the most common type of runtime errors are ones that cause performance issues. For example, suppose you're responsible for coding an enemy's AI. When you test, the enemy behaves fine, but the frame rate tanks and the game eventually crashes anytime the enemy is on screen because it turns out your code is inefficient. Runtime errors are tricky because they can't be detected automatically or just by looking at your code. The only way to find them is through testing, and when you do find them, fixing them often involves rethinking your whole approach to a problem. Even when professional game teams have QA and testing departments, it's still the responsibility of individual developers to make sure their code works as expected and doesn't have any obvious bugs before they hand it off. Working in small, manageable chunks and testing frequently are the best ways to ensure your code clears this bar.